Yo, what up, everybody? Welcome to day 5 of my journey on becoming a Web3 analytics expert. Today, we are going to go through the segment 3 of the Metric Style Web3 Analytics 101 course. So, to get right into it, this is the recap of easy mode. Let's start off with this query right here, put it in the studio, and then talk about what it is. So, let's play it. While it's executing, it looks like it is trunking, separating the week blind of the block timestamp as date. It's going to group by the week and the platform. Going to count the transaction count. It's going to count. So it's going to count the tickets, and then it's going to count the distinct swappers. Going to do the transaction count by unique swappers as tickets per wallet as an average from the Ethereum Core Easy Dex swaps for the past year. So we'll go here. I believe in the video they made a bar chart, so let's do that. We're going to do, instead of a line chart, we're going to do a bar chart. The x-axis will be the date. Just get rid of this chart. Add a new bar chart. Axis will be the date. Y will be the transaction count. The Y line will be the unique swappers. Then we're going to group by transaction count, or group by, not transaction count. Having a little error right here. Back to app. Go back to the studio. We'll group by the platform. So we can see the transaction count as all of these. So we have, it looks like we have Uniswap V2 and Uniswap V3. So I think we can do a case here just to get it into Uniswap so we don't have to separate the two. We can do case when platform, like we learned earlier, like Uniswap wildcard, then it's going to just be Uniswap. So we'll just group them all into Uniswap and see if we could get rid of the V2/V3. Else, it's just going to be the platform. We'll end it as platform. So let's see if that works. So now we just have it as Uniswap because majority is a Uniswap. So if we take out Uniswap, we could see that the second is SushiSwap. And we'll get it back. All right, so this I don't understand why. Let's just copy. Oops. Let's copy this part right here. I just don't understand why the Y line, how could you have more unique swappers than the transaction? It doesn't make sense. So maybe it's because we did the case. So let's exit that. It's still over. I don't know. That seems like it's an error. Right here, it's fine. But over here, there's more. Maybe it's just counting the cumulative people, and they're not making that many transactions during this day. That might be it. So we will just continue this just to do it Uniswap, and yeah, that's how we could see the unique swappers versus. Get rid of this comma. Oh, you need to have this comma. I don't know why it worked before. Let's see what I did differently. Oh. Works down in the chart. Oh, so now it works again. Okay, cool. So because we are grouping by platform, we can compare these metrics directly with some visualizations. Weekly active wallets, total weekly transactions, transaction per active wallet. But if we don't leave the data, we may be missing something. Analysis requires familiarity with the subject, domain knowledge. We can compute these metrics without having use Uniswap because the data table is clean and presented in the form of an easy table. So to better understand this analytical bounty, one should research their subject. Let's start by going to Uniswap and poking around. We'll skip this part. Their homepage is a classic landing page, so let's check their blog for recent news. Right away as of August. 2022, we see something of note. Two separate Uniswap v3 is referenced. So if you want to check out the Uniswap stuff, you can, they had a new v3. Most of the stuff is on v3 now. The current stats page show 4 billion TVL in Uniswap v3 and less than a billion in 24-hour volume. Seems like a lot, but we need to look at some relative figures to get a feel for that. There's a link on this page for V2 Analytics. Seems like a good place to check. 1.5 billion TVL, pretty good, and the less than 24-hour volume. That's a lot less. So our clean, easy table above is missing all of the unique Uniswap's volume. We have found out in the advanced. Let's check the docs. This table currently contains swap events from the fact event log table for Uniswap and SushiSwap, along with other helpful columns, including an amount USD when possible. Other DEXs coming soon. Okay, so probably how do we get Uniswap v3 data for our analysis? Well, the docs for easy DEX swaps says the Uni v2 and Sushi data is coming from the fact event log, so this may be a good place to start. select all from Ethereum core fact events logs, where this can get confusing. What should you look for here? We can always search Etherscan for Uniswap and see what comes up under tokens and labeled addresses, but fortunately and unfortunately, there are a lot of contracts out there. The dimensional labels tables are an option, but again, lots in there too. So let's get directly to the point. The activity to be modeled out is a swap. So let's look at a swap. Interacting with a protocol is not only a great way to learn how it works, but it also creates some sample data you can investigate. It cannot be stressed enough, but always be careful about the web page you are on. Verify that the Uniswap you are about to connect is a legitimate protocol. Anyone can buy an ad on Google, and phishing is all too popular amongst scammers. So like I said earlier, well, not today, but Twitter, I think, is probably the best place to go to find the official link, the official Twitter page. And you could tell because they'll probably have a lot of followers and stuff like that. It's pretty easy to check out if you check out the Twitter page and then get the official links through there. And if their Twitter is hacked, it'll be all over Twitter. So it's easier because Google doesn't check who's putting ads out, which they should. Open this transaction in Etherscan and find in the fact transactions. We'll skip that. So JSON. So we will, these are the same ones. Oh, select JSON tickets. So we'll look at the JSON text in all its glory, as they say. Oh, there are no more text JSONs anymore. Well, we'll investigate, select all, and see what it is for. See if we can update. We'll get rid of this. Close this down. So we have from the, what are we? The fact transactions. We have the block hash. It's not what we need. Token hash, from address, to address. Nope. Input data. Probably not that. RS. So I believe now it is in the fact event logs. So let's see. Fact event logs. Let's see the easy to coded event logs and see what we got. Here we go. I believe we need the decoded log right here. So we got all this good information right here about the event is a swap. So if you're looking for just swaps, you can see the liquidity, the recipient, and all of that stuff in the decoded logs. I think they're talking about not the decoded ones though, so maybe let's try the fact event logs. Oh, fact decoded event logs. Cool. So it's executing and bam. Token hash. So they have the same thing, the decoded logs. Transfer swap approval. We have that, the swap. So they decoded it for us, which is awesome. That's pretty fire. What can I say? So let's continue on. Text JSON in all its glory. Here it is through here. This is the whole JSON file on the Etherscan. Text JSON data item or object is the meat of the transaction. It contains the output data from the activity we just performed on Uniswap. This ugly mess is a gold mine of information. The primary thing to notice is the structure of the block, which is much easier to read when formatted properly. like we did here, we can copy the contents and go over to something like JSON formatter.org for sanity's sake. Dictionary structure. For example, it is a data structure made up of key value pairs separated by commas. We can see right away something familiar in block number, this number, where the key block number and value equals 153473444. If we want to get this data, we can use the key in one of the following ways. Using text JSON block number or text JSON colon block number. So let's try it with the decoded log. Okay, so we'll just do where swaps and then we'll get the amount one. So let's see if we can do that. So it'll be select. Let's go here so we can reference it quickly. We'll go down to fact, event logs, fact decoded event logs. So we'll select decoded logs colon amount one, where the ticket is that, and event name equals, is it capital? Swap. So let's see if it'll bring it back the amount. So here we go. So here is how you can go into the amount or dissect it and then go into the amount log or the decoded JSON files. Objects can hold other objects. Thus, the value of one key can be a key value pair itself. This is another reason to use a formatter, as nested objects will be easily to spot due to the extra indentation right here. So if the above has a value for txJSON, then txJSON key 1 equals value 1, where txg key 2 equals nested key to nested value. And ultimately, key 2 nested key equals a nested value. So if there are more branches down the tree, just keep on adding colons to each key right here to get the value that you desire. So back to the goal at hand, getting to logs. Refer back to the JSON above or in your editor or in another window. On line 24, we see that the word logs, it's quite indented. We see the word logs, it's quite indented. So we can tell that logs is within receipts, which is within the ticket JSON itself. To access and return the logs, the full part of txJSON, we simply need to ask for it receipt logs. Since we're not in the ticket JSON, let's select all and see if we can find a way to do it over here. So the decoded logs all just have one. The full decoded log. So let's do data name. I believe. So if we do select full decoded logs, data name. Wait, if we do name one, does it do the first one? I think actually we might have to put another. Let's see if that works. See if we can figure out how to break this down. So maybe if we go data name one, forgot how you do the first one. If we just do name. So in the future, I'll figure out how to do each name since there are more than one name. But you can get down to pretty far. But I believe you just have to have the positioning in the array. Maybe you could do data one. Let's see what this brings up. Yeah, so I'm confused on that. Oh, here we go. So maybe let's try. There we go. Data. So it looks like the brackets are not working right now. Oh, maybe I could go data one and it should bring up the decoded. There we go. Oh, if I bring up 2, let's see what happens. Are they in a hierarchy? So it seems like there's a little struggle right there. So usually if you do that with the array, then if I put it in these brackets. Nope. All right, well, we'll skip that for now. Let's take a look at the logs at Etherscan. Notice there are 4 multiple logs in one transaction alone. Oh. So if we go data 1, maybe name. There we go. So that's how you would do it because there's multiple datas right there. You select the specific data with the array. So if it's the recipient, we do data 2. It'll be the amount. Data 3. So this is how you parse through the JSON files. Boom, boom, boom. So let's just look at that real quick. So we went through decoded, 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 decoded right here. Since there's multiple decodeds, we had to specify which decoded it was. That's what we did. So if we wanted to say, let's get squirt price, square T price, we'd look down and we'd go 1, 2, 3, 4. We'd go decoded 4, name, and then it should bring up the squirt price. The hell? It just was working. Let's see what I did differently. Oh, because it was data. So let's look at this one more time. I see. Bear with me here. Oh, so we have to go into the log and then data. Decoded is not it. So data, there are different dictionaries. So if we go fully decoded log, sorry guys, data 4, then the name, it should be the squirt price. There we go. So that's a way that you can parse through the decoded data and then you can organize it and all of that cool stuff. So you can go way deep in there, super deep. Okay, so take a look at the logs on Etherscan. Notice there are 4 logs for this loan transaction. To represent these events, they are stored in a list known as an array. Arrays are denoted with square brackets and contain 0 or more pieces of data. Yes, they can be empty. For example, A equals the fat cat is an array A of 3 full strings. We can access each of these elements by their index, which starts at 0. How do we index the array? With square brackets. A0 equals that, A1 equals fat. Oh, I must have miscounted then because I needed to start at A0. If we do A0, what will come up? Sender. All right, so guys, remember, I just got lucky that the last ones were the same. Start with 0. So going back to our logs, to access each log, we simplify index in the array, looking at either the full JSON or on Etherscan. We can see that within the logs, there's a decoded object containing an event swap. As we are looking to identify Uniswap v3 swap transactions, it's probably a good place to look. So the swap log right there, big mess, but to get into like the liquidity, you would go to, we'll just skip that. And then, now we can't assume that the fourth index 3 log is always the swap event. Further, we might want information like token info and other logs. There's a way to flatten a list like logs and easily access each piece in an array. However, there's an even easier way to get each log and the decoded information within. Remember the ethereum.core event logs? That's kind of what we went through. Since it doesn't have the TX JSON anymore. Here we have the 4 logs from our swap easily cleaned up in order. So why did we waste time learning about dictionaries and arrays? JSON is a very prevalent data format, and knowing how to traverse the nested structure, which we did just with a different thing. Even in the flattened fact event logs, we have a column event inputs with JSON data that needs extracting to be useful. Let's take a look at the event inputs from the swap log where it's swap. This is what we did right here. If we want to build up some metrics or analysis on Uniswap v3 pools, we need to be able to access this data. Looking in depth at the logs, we can start to build answers to question like, how do we identify the tokens in this swap? And which one is amount 0 and versus amount 1? Which pool is the address using? And once we can do that on an individual level, it's a breeze to compute over a large set. Recall in the raw logs, there are other pieces of interest. In the transfer events, DAI and wrapped ether are identified, and we can match the amounts with amount 0 and amount 1 in the swap. Curious about the pool info? As they say, follow the money. Let's take a look at a piece of the 2 transfer logs up close. Here, it looks like wrapped ether 9. Recall, this was a swap of 50 DAI to 0.02 wrapped ether, and we see that reflected in the logs. Here, right here. With the respective to from address. DAI is leaving the swapper's wallet in the direction of the pool, while wrapped ether is being transferred in the opposite direction. We can confirm or identify the pool by checking Etherscan or the labels table. Label table. Let's select here, and we should see some indication of DAI swapping ether. Uniswap. There we go. Uniswap DAI ether. Boom. Cool, cool. Now that we know how to access the data nested in these JSON objects, the only thing left to do is to apply the data transforming techniques learned in the previous SQL lessons. We can use CTEs to build temporary result sets from the logs, aggregate activity over a long period of time, and bring in identifying info from contracts and labels with joins. Using all of these ideas and techniques together takes time and practice. Fortunately, there's some prompts for us to try this out on the next page. All right, let's dive deeper into the Snowflake semi-structured data types. So here is the Snowflake. Boom, 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 boom. So Snowflake documentation is a good thing to go through if you are trying to learn Snowflake, which I am. So maybe I'll be going through that and boring you guys another day. But we finished the segment 3. That was pretty quick and easy. I guess not that quick, but have a great day. Happy Aloha Friday. Have a great weekend. Keep dataing. Peace.